Because of the inadequacy of using just a right triangle to model and make use of sine, cosine, and tangent when dealing with negative angles, or other angles greater than or equal to 90 degrees, one can utilize the unit circle. The unit circle is a circle with a radius of 1, whose center is at the origin of a Cartesian plane drawn like so. So here is the x-axis, and here is the y-axis. Here is a circle. A right triangle can be drawn like so. To show how the right triangle relates to the unit circle, with this angle as theta. The cosine of theta, which is an angle at standard position whose initial side lies on the positive x-axis and whose terminal side lies anywhere else on the plane, which happens to be right here, and is equivalent to the x-coordinate of the point on the unit circle that is formed by the intersection of the terminal side and the circle, which is this point, or the length of the right triangle. The sine of theta is equivalent to the y-coordinate of the same point, or the height of the right triangle. So here, x is equal to cosine of theta, and y is equal to sine of theta. And the tangent of theta is equivalent to the value of the y-coordinate over the value of the x-coordinate, or the slope of the hypotenuse of the right triangle. So here, y over x is equal to tangent of theta. Knowing that the radius of the circle is 1, we see that the trigonometric ratios hold true when you try to find the sine of an angle of 90 degrees. Like so. Once again, here's the y-axis, here's the x-axis. Here's the 90-degree angle, and here you can see that the length of the radius, which is 1, is equivalent to the sine of said angle. And the length of the radius is also equal to the cosine of an angle of 0 degrees. So here, the radius of 1 is equal to this angle, which you can't see because it's 0 degrees. So therefore, the radius is equal to the cosine of 0 degrees, and the radius is also equal to the sine of 90 degrees. As an example, if we know that the sine of a certain angle is 0, and the cosine of a certain angle is -1, we can use the unit circle to find that angle. If we draw the unit circle, we can see that point P on the circle here has coordinates -1 and 0 on the Cartesian plane. So, in order for it to be a Cartesian plane, you indicate that it's y-axis and x-axis. So, this means that the sine of this angle is 0, and the cosine is -1. So, as we can see, the angle is a straight angle, which has a measure of 180 degrees.